Hello, everyone. Hope you had a chance to explore our virtual booths and take part in some of the contests during the break. We're excited to have you back for the next session, and I think I'm personally very excited for this session. I think during this session, we're exploring the evolving landscape of software quality in the age of AI, and I think we're deeply honored to be joined by Elizabeth Hendrickson, founder and CEO of Curious Duck Digital Laboratory, and she's a very respected voice in the world of software testing and quality engineering, right? And Elizabeth has long been at the forefront of driving best practices in software development, from agile to DevOps to modern testing approaches. And I think her work has shaped how teams across the industry think about building quality into their products. And relating on the same lines, I think her topic couldn't be more timely. She's going to cover the modern quality engineering in an AI driven world. And I think as AI code generation becomes mainstream and AI is also becoming a core feature in many products, I think the pressure is at all time high for quality engineering in general. While DevOps and Agile have improved software delivery over the past 2 decades, there are problems that are yet to be solved. And I think there are organizations that are already struggling with quality, and I think they're also now at a greater risk for the same reason. In this session, Elizabeth will challenge the traditional models of quality assurance that rely very heavily on outdated metrics and inspection. And she'll share why the future of quality lies in actually embedding quality deeply into software delivery and measuring success through real outcomes like SLAs, DORA metrics, and customer impact. And I think when you view it through this lens, quality engineering isn't a process, it's kind of having a competitive advantage. And with that said, please join me in welcoming Elizabeth Hendrickson. Over to you, Elizabeth.
Thank you so much, Pooja. Thank you so much. And yes, you're right. In this AI-driven world, all of the outcomes are so much, cycle times are increasing so fast, and the outcomes are so much more critical now. I've been in this industry for over 30 years, and I've seen various inflection points. I was here for the rise of the PC. I was here for the rise of the web, and I'm here to say that AI is fundamentally changing our world. In order to appreciate that, I do want to kind of go back a little bit, just enough to appreciate how far we have come as an industry. We can see the trend, the delivery cycles, even before AI, were getting faster and faster and faster. When I entered the industry, it was very normal to have release cycles that were in the weeks to months, in the months to years. And the kinds of practices that we had then were very appropriate for that kind of cycle time. So we would have these phases, and we had time to do each step separately. And then with the rise of the web, we had a phrase back then, web time, which indicated that we were going so much faster. We were delivering, typical was within weeks to months. In the early days of the web, there were a few, very, very few outstanding organizations that were able to deliver in hours to days, but it was incredibly rare. The normal was weeks to months. So then we see the rise of Agile and DevOps, again, fundamentally transformed our industry, and we went to days to weeks. And in the age of AI, well, we're going to get there. So let's go back to 1999 to appreciate how far the industry has come. Back then, it was typical that you would have a big bang release. And by that, I mean, we actually didn't know for sure how everything was going to work together before and in the real world before we released, for a variety of reasons that we'll talk about. It was typical to have phases and quality gates and sign-offs and massive documents that described the market requirements. So the market requirements document, MRDs, were answered with product requirement documents, PRDs, which were answered with technical specifications, and then that was used to create test plans. So these massive documents and a huge amount of time authoring these massive documents. partly driven by some very strong silos, particularly between dev and test. So we would have this notion of we have to have independence. One of the common phrases was we can't have the fox watching the hen house. And we would have these artisanally handcrafted builds where somebody in configuration management was literally deciding which versions of which DLLs to put onto into the official build. Then we would have manual regression testing, or to the extent that an organization adopted automation, it was usually with clunky and expensive commercial test automation tools where the organization couldn't justify giving everyone a license, and so only a few people would have access to them. This was the world in 1999. Agile and DevOps did literally change everything. So we replaced the bloated PRDs, market requirements documents, and product requirements documents with the notion of stories and roadmaps. Teams were aiming for frequent incremental deliveries, tooling of all kinds vastly improved. We see the rise of open source. The builds now can be automatically generated with CI/CD pipelines. Test automation has been democratized, so everyone has access to the same test automation frameworks. And the automated deploys, the automation that we got in the DevOps movement, made automated deploys are so much faster and safer. And we've got a rise of observability tooling to support testing in production. But the really bad news is that not everybody made it out of 1999. Like I said, the future is here, but it's unevenly distributed in a lot of organizations. Those organizations are really, really, really struggling. They're struggling with inventory on long-running branches that isn't yet ready to deliver, which is the same as what we had in 1999, where the source control has changed. But the idea of having unshippable inventory checked in somewhere in source control, that was common in 1999. And then we had to spend time getting it to the point where it was shippable, and we would have a code freeze and. Teams are still fighting with slow, fragile tests, which is the same as in 1999 if the QA group didn't really know what the software was designed to do. If we had that drift between the intentions and the execution and the testing, then we would have all of these bugs polluting the bug system, and we would have fights over it's a bug, is not, is to, is not. It's the same thing. It's just in a different world. The human factors have stayed the same. The silos and separations still cause misalignment. Technical debt still plagues code bases. And incidentally, some of these code bases are older than the Agile Manifesto. So they had their start long before modern practices were either the normal or even possible because the tooling didn't exist yet. Not surprising that we have late-breaking surprises that derail plans, and those surprises can put teams under pressure. And the more pressure the teams are under, the more corners typically get cut, the more late-breaking surprises we have. So it is, again, not surprising that we have serious quality problems. Organizations today continue to be plagued by these problems. And I want to explain kind of what's going on here briefly before we get to the AI part, because I think that it's really important to have this mental model of what's actually going on. Back in 1999, we had these phases. We would have an analysis phase, we would have a design phase, then we get to coding, and you're going to notice that there's this chart where the y-axis is speculation. What does that mean? That is where we are making assumptions and guesses and moving forward without having empirical evidence to say what we're doing is on target. So when we're analyzing, we're making a bunch of assumptions about what the market wants. We are speculating that when we listened to customers, what we heard was the right thing. When we're designing the software, we're speculating that we're on target that what we're designing is actually going to meet that need. When we're coding, we're speculating that the code is all going to work together, that the code is going to meet the actual needs. And we're coding, and then we get to testing, which in many organizations in 1999 was the first time we had any indication whatsoever about whether or not things were going to work together. So you see the speculation curve start to come down, and then we release, ta-da, we declare victory, we win, except all of this area under the curve, all of this is risk. And the thing about risk is it's invisible. We don't know the extent to which we're incurring risk. We can have an intuitive sense. This feels risky, but there's no way to quantify risk or make it truly visible without the empirical evidence to tell us that something was not as we expected. So Agile to the rescue, right? The theory is that we are delivering in small increments. So there is still that risk. We still are speculating. We have to. There's no way to not speculate that what we're doing is on target for what we intended. But we're doing that in small amounts before we release. And then we've got concrete empirical evidence about the extent to which the thing that we delivered did what we intended it to do and met the actual market need. So small amounts of risk, it doesn't accumulate, and this is how we're able to get the benefits that Agile says that we should get. Most organizations aren't actually all that Agile. Even if you've adopted Scrum or Safe or pick your favorite flavor of Agile, it is very easy to do Agile without actually being Agile. So what's happening there? Let's look at it. Theoretically, when we release, theoretically, those increments that we're delivering, theoretically, they're done. They're ready to go, even if they're not deployed yet. But really, done is truly running tested features in production. So theoretically, we're getting to that point frequently. In reality, for many organizations, I don't want to say most, but for many organizations, they're kind of done. Maybe they didn't do that performance testing or the security penetration testing, or maybe there's some accrued technical debt with the idea that we're going to do a stabilization sprint later. Or maybe we've done all of the things we believed that we need to do, but it's not actually released, so we don't get the empirical evidence. That gap is going to build up. Sprint by sprint, iteration by iteration, as long as we haven't done all the things, that gap builds up. And what does that mean? Well, we're speculating. We're speculating that that gap is okay. This is fine. And then we're realizing, we'd better start like actually finishing those things and fixing it. Panic. And then we release. But all of that speculation that built up, that's all risk. And too often we end up with some very angry stakeholders. Notice that the area under the curve as risk looks exactly the same as waterfall. This is why in your organization that is theoretically doing Agile, but not getting the benefits that Agile promised, this is probably what's happening. Risk is really hard to quantify, but we know that AI adds to this risk, and this is where the AI piece comes in. See, the thing is, in an organization that is already struggling in a deterministic world. So in a deterministic world, we set our expectations for what we intend to accomplish. We execute on that. The software does what we programmed it to do. That's a deterministic world. AI is an inherently non-deterministic world. If you're building Gen AI into your product does things that nobody directly programmed it to do. LLMs are famously not deterministic. That's what they do, is they generate things that nobody told them exactly how to generate. They generate it from the context. And similarly, if you're using an LLM and programming your system, that's not deterministic. So we take organizations that are already struggling in a deterministic world where the software only does what a human programmed it to do, and those organizations are going to be in a world of hurt in a non-deterministic world where cycle times just keep getting faster. Some of the risks, if you're building a chatbot into your system, well, we already know that there have been lawsuits and companies have been held liable for what their chatbots did, like Air Canada, who was found liable when their chatbot gave bad advice that was counter to the official policies of the company to a traveler. Similar thing. This was I believe this was the Cursor IDE, which I use every day. I love Cursor. Cursor's great. However, it did give some bad advice to users about I believe this was about the licensing. And so it was kind of ironic that an AI IDE had a problem with their AI chatbot, but it gave bad advice. And LLMs famously hallucinate. So lawyer had to apologize because they took results from ChatGPT that claimed that a given the an entire legal precedent and the lawyer didn't check it. So we know that when we add Gen AI to a product, that's going to increase risk. And then there's vibe coding. See, I use Cursor every day. It's incredibly powerful. I am very much a fan. I love the fact that I can do things with Cursor that, frankly, I wouldn't have bothered doing. Bother is a strong word. What I really mean is that it would not have been worth the hours I would have had to spend. So I'll give you a concrete example. I built an application and I knew that I needed to do some CSS cleanup, and tweaking CSS settings is so not my favorite thing to do. So I got Cursor to help me with it. And I realized as Cursor was helping me with it, that I could get Cursor to implement dark mode. That is not something that I would have prioritized, but it was near free because Cursor could implement it so much faster than I could. So from my point of view, Cursor makes me almost infinitely faster because, or is an infinite productivity boost because I can tackle things that I otherwise wouldn't have tackled. So I view AI IDEs as kind of like a mech suit. They enable me to do heavy lifting that I otherwise really either wouldn't have done or could not have done. The problem, of course, is that it also has the capacity to create chaos faster than ever before. At this point, we've probably all seen this particular set of posts on X where and I'm really impressed by this person who left the posts up. They didn't delete them. I took these screenshots just yesterday, but the first post on March 14 was, hey, look at me. I built a thing without having to code anything. And the second post here from 3 days later was basically, I'm not technical and this thing is doing stuff that I don't understand. So that mess around to find out cycle got really short, 3 days. And this is happening because Gen AI will do things on your behalf that you don't understand. So if you're a programmer and you maybe don't have the most rigorous process as you're coding, if you already are kind of coding, code it up and then find out later, you're gonna have so much pain. Cursor will make changes beyond what you ask it to do. When I was doing some of that CSS tweaking and asking it to clean up my interface, it added headings that were visible to the user that I didn't ask it to add. I've gotten to the point where after every single prompt, I do a git status to find out what it changed so that I can roll back any changes that I disagree with. That working in tiny, 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 tiny steps, that's for some programmers, that's not how they work. But if they tend to work in really big steps, they're going to run into a world of hurt because every subsequent prompt might undo all the good that you got and add a bunch of stuff that you didn't intend. It will, in fact, make terrible changes and suggest really stupid designs. One of the things that's happening, I discovered, I have a bad habit. I tend to comment out code instead of deleting it if I think that I want to come back to it and do whatever work was necessary to make it actually production ready. But I don't want to implement it right now. What I should be doing is trusting the source control system and having much better habits around feature branches so that I could come back. But I'm working solo on my project, so it's not clutter that anybody else has to deal with. But it turns out that Cursor will use that as part of its context. And so one of its really overcomplicated solutions, when I asked it, the advantage of these Gen AI systems is that you can ask it, why did it do that? And it told me that it was trying to preserve the functionality of, and then it showed me the commented out code, that I didn't need it to preserve functionality around. So it has a reason why it's doing stuff, but it might be something that if you're in a code base that is a legacy code base where you don't really fully understand that code base, you might not understand how it's making the decisions that it's making. So there are these risks here, and every habit you have as a programmer that isn't that super rigorous way of working, I don't want to accuse anyone of sloppy habits, but if you have any, Gen AI is just going to make your life harder. And so that is something that you want to think about. Now, let's come back to doing the same thing, but faster to keep up with the demands of faster cycles no longer works when the delivery cycle is measured in hours to days. They just simply don't work. And that brings us to quality engineering. We need it now more than ever, but I want to reframe what quality engineering means. In a traditional world, if you go back to the traditional literature about quality engineering, you'll find entire books on how to use defect-based metrics to assess quality. That's an example of a thing that doesn't work anymore. When your cycle is hours to days, you don't have a whole phase where you're discovering defects and then get to see what the trend lines look like on those defects. That's not a thing anymore. So I want to reframe quality engineering in terms of deliver value sustainably. Let me explain this. What this means is that quality engineering is the set of practices that enable us to deliver value sustainably. That means that we're shipping a known quantity. So testing is certainly part of this. Part of delivering a known quantity is that we have the automated tests, but that's not the only way we deliver a known quantity. We're doing so at a steady, frequent, predictable cadence on short cycle times, keeping our inventory of in-progress work low. When we deliver things, they have actual value. It's a lovable product that delights customers, and if they're surprises, they are the good kinds. Engineering concerns no longer dictate business decisions. So that means, what that means is that we are aiming to deliver the value that the business needs without saying to the business, oh, you can't have the thing, because as engineers, we have decided part of delivering value is really making sure that we're delivering what the outcomes that the business needs with software. Every delivery has to unlock new capabilities. Now, some of those capabilities may be internal capabilities, like when you deliver a walking skeleton that does not do anything yet, you're still getting business value because now you can start to build on that walking skeleton and have incremental delivery on that. So I don't mean that we're a feature factory, but what I do mean is that as we think about deliveries, we're thinking about what is the business value that we're delivering. And we're doing that sustainably so that we can do it over and over and over again. That means we're keeping a healthy code base, which is harder in the age of AI with Gen AI IDEs, unless you're really paying attention, like I mentioned before. We're making sure the team stays healthy, and we're making an appropriate investment so that we can, or we're making appropriate investments so that we can keep the costs appropriate for the business growth, with no heroics, no single points of failure. And we're able to keep that same or even faster pace over time. So that's what it means to deliver value sustainably. Now, how do we get there in this world where the cycle is hours to days? Let's take these one stage at a time. And I've broken the software delivery cycle into 3 phases, or phase is the wrong word because we don't live in a phased world, but 3 sets of activities that we're doing at any given time. Ideating is when we're deciding what we're going to build. In this world, it's already true that if that is really important to include everyone who will have a hand in delivering the thing, in the implementation, in the execution, in the ideation. But it's even more important now to include QA and data scientists and ML ops, because you have to operate this thing. You need to include them from the very start of an idea so that we get all those perspectives in applying risk-based thinking about What are some of the assumptions that we're making? Which of those assumptions are unproven? How are we going to know if something goes wrong? And include those risk detection criteria and the always and nevers in the acceptance criteria. By always and nevers, I mean, for example, Air Canada probably now it has some way to tell it or prevent their chatbot from providing advice that goes contrary to the company's policies. And so the chatbot should never provide advice that is contradictory to the company's official policies. So thinking about that in advance is super important. And leveraging AI tools to help with simulating those edge cases or to help you with thinking about the range of data that you're going to have to deal with and thinking about failure modes, you can actually leverage AI to help with all of this. As we go to deliver, so we're executing. All of those rigorous technical practices that maybe it's been hard to get buy-in to invest in, like getting buy-in to invest in going back and adding unit tests to a legacy code base, it's really critical now. You really have to. And if you're struggling to make this case to your management, then what I would suggest is that you go back to the idea with them that what we're trying to do is get to a point where we can deliver value sustainably and bring it back to the business outcomes that we want to deliver, because that's what everybody wants. And then explain that in order to do that in this world, we absolutely have to make the investment so that we are delivering a known quantity. It also means investing in the build and test automation. So all of those flaky tests that kind of people say, kick it again, it'll be fine. Got to make that investment now. Embedding SREs and QA in squads so that you've got the fast feedback going, having a completely separate QA entity that is going to test after. It doesn't work in this faster cycle. And exploring early and often. It is critical to explore for these risks to discover during development where you perhaps your system is capable of violating an always or a never. When we get to operating and maintaining, having automated canary releases and using real-world observability to continuously validate the outcomes, having some way to tell if something goes wrong before you get the lawsuit, and aligning those ops metrics with the original quality goals is essential. And I also solidifying the rigorous technical practices to make releases safer and faster is absolutely critical. Ultimately, what this boils down to is organizations that are already operating at the DORA elite level are going to be fine. They're going to be able to thrive in this new AI world and get all those benefits that are promised with AI, but the organizations that are already struggling to deliver a deterministic system at the pace that the current market demands, those organizations are going to be in a world of hurt. So quality engineering becomes a strategic advantage. I would argue that what Agile and DevOps are giving us are quality engineering practices that enable us to deliver value sustainably. And so that is the call to action, is to make the investments necessary to improve your quality engineering stance. So that means you're going to streamline your cycle, you're going to design for testability up front, you're going to deliver a known quantity, and you're going to have mechanisms to detect problems in production early. I do want to give a shout out to my co-authors on a paper that will be coming out this fall from IT Revolution titled Modern Quality Engineering in a Post-Agile, Post-DevOps, AI-Driven World. John Willis, Michael Edinson, Joseph Enox, Jeffrey Frederick, and Cameron Kazimpour. We all got together about a month ago to brainstorm, and a lot of the content here is partly thanks to their ideas as well. So huge shout out to them. And that's what I've got. Thank you so much.
Thank you so much, Elizabeth. I think that was wonderful. Those are really nice insights, and really, really enjoyed your energy in expressing your thoughts. That was really nice. And